Okay, we need to continue talking about perimeter because an area, because once we know how to find perimeter and area, there are other problems that we can solve that are a little bit more complicated, and I want us to look at some of those. So let me show you a couple of examples of these kinds of things. First, if I had a landscaper that was laying down turf, so that's like the artificial turf that they put on football fields and stuff, or outdoor carpet that they might put on a playground. That's what we're talking about here. And here we have a picture of our playground, and we know that the turf is going to cover the whole playground except for a square sandbox. Okay, so here's the sandbox right here. Okay, how many square yards of turf will the landscaper use? So the first thing we need to do is read the problem. We need to find out how many square yards the landscaper will use. What did he give us? Well, we know that the turf will cover the playground, but it will not cover the sandbox. So I've got whatever this area is that I need to find, and then all but this is going to be covered. So the length and width of the playground are, well, there's 25 and 15. So 25 yards and 15 yards. The side length of the square sandbox, notice it says square, is 6 yards. Now I need a plan. Oops, there we go. Now I need a plan. So what can my plan be? Well, let's see. I can maybe not figure out all of that all at once, but can I make a plan to solve the smaller parts of the problem? Can I figure out the little bitty parts and then add it all together? Well, sure I can. So how many different shapes do I need to find the area of? It seems like I should need to know the area of the playground first. And then if I'm going to find and cover the whole playground except for the sandbox, seems like I probably need to know the area of the sandbox too. So let's say the area of the sandbox is the other part that I need to know. Then if I know, let's go look at the picture again. If I know this whole area, and then I also know this little bitty piece that's not being covered, could I not subtract the area of the sandbox from the area of the playground? That seems like a good plan to me. So basically, here we go. We're going to find the area of this whole thing and this little thing and subtract this from this. Well, let's find the area of the playground first. The first thing is going to be, we got area equals length times width, which means 25 times 15. I can't do that in my head, and neither should you. So let's see, 25 times 15. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. Drop my 0, and there's 25. Add that together, and there's 5, there's 7, and there's 3. So 375 square yards is how much turf I would need to cover this whole thing. But I don't want to cover this. So what's that? Well, the area of a sandbox of a square is going to be the length of the side squared, or times itself. Length times width, same thing, side times side. 6 times 6, because a square has 4 equal sides. I do know this is 6 times 6 is 36. So 36 square yards here. So this whole thing is 375. This little thing is 36. Now let's subtract. And this is already done for us, but let's look at it here. the area of the sandbox from the area of the playground. We have 375 minus 36. And that gives us 339 square yards. So the landscaper will use 339 square yards of turf to cover the playground. Not too bad. Let's look at another one that's not all done for us. And it's a different kind of problem. It's an area. No, it's not. It's a perimeter problem. But it's kind of a weird shape. Looks kind of funny. What can I do to figure this out? How many meters of fence? So Zach's planting a garden for a museum, and a fence will be around the sides of the garden as shown in the diagram. So this is the shape of the garden. It's not square, and it's not rectangle. How many meters of fence does Zach need? Well, we know that what I need to find is the perimeter of the fence, or of the garden. What information am I given? Well, I'm given this side here plus this side here. That looks like it might be a rectangle. So I'm given partial sides of two different shapes, because look, if I draw an imaginary line here, that looks an awful lot like a square with 5-meter sides. And if this is a rectangle, that means that this is 18. And this whole thing would be 20. So I'm given dimensions of a rectangle and a square. So length and width of one rectangle and length times width of one square. So what's my plan or strategy? Looks to me like I could find one of two things. Well, let's see. I could just add all these together, couldn't I? Well, except that what is this? Well, it's going to be 20 minus this amount. Except that it's not really minus this amount, it's just pushed out here. So really this is the perimeter of this rectangle plus these two little 5-meter sides. So I can find the perimeter of two shapes, or the perimeter of the rectangle, and then add the extra. So find perimeter of rectangle and add the extra sides. Add extra sides. Okay, so let's solve it. Let's see, there's 18 times 2. We know perimeter equals 2L plus 2W. So this is 20 all the way across. That would count this too. So let's just count this as 20. P equals 2 times 20 plus 2 times 18. But I also need to find the perimeter of the square. So let's see, we've got perimeter equals of the rectangle, P equals 40 plus 36. So the perimeter of just this rectangle right here would be 76. Okay? Except that I don't just have this rectangle here. I've also got these two pieces here. I don't really have to count this again, or this again, because it's already been taken into account. But I do need to count these two 5-meter sections. So, plus, that's 5 also because that's a square. So that's going to be plus 5, plus 5, plus 5, plus 5. Now I can say the P equals 81 meters. So, to answer the question, how many meters of fence does Zach need? He needs, let's see, Zach needs 81 meters of fence. Because the garden is shaped like a rectangle and a square put together. Is two shapes put together. All right, that's what we're going to do. We're going to have some problems to work today or tomorrow that are sometimes irregular shapes like that, sometimes finding the difference in shapes like we worked before. Okay, so we're going to work practice problems tomorrow. I want you to take good notes and come up with a couple of questions about what we're doing, or at least have the questions ready if you have any. Okay, we'll see you tomorrow.